Recording in progress.
Hello and welcome. I'm Dr. Pauline Fu. In this video, I will go over some problems for experimental design. So the first question is 12.2. Accounting and materialism. A study of materialism traits in accountants was published in Behavior Research in Accounting. The Macchiavelli describes negative character traits such as manipulation, cunning, duplicity, deception, and bad faith. A March rating score was determined for each of the sample alumni of a large Southern West university. The accountants were then classified as high, moderate, or low March rating scores. For one portion of this study, the researcher investigated the impact of both March score classification and gender on the average income of an accountant. For this experiment, identify each of the following. 1. Experimental unit. So what is the experimental unit? The experimental unit is accountant alumni. Accounting alumni, that is the answer for A. B, response variable. So response variable is the one on the y-axis. Okay, so what is the response variable? So the purpose of the study is to say on the average income of accountant. So the average income of accountant, that is the response variable. Question C, factors. Okay. Question C, there are two factors. One factor is the factor is March score, that is one factor. The other factor is gender. So those are the answer for C. Factors, March score, and gender. And question D, levels of each factor. So let's take a look at March score. For March score, you have high, moderate, and low. So that is the answer for question D. Okay, for March score. And for gender, depend. Traditionally, gender is divided by male, female. If you want to be more inclusive, gender could be male, female, LGBTQ. Okay. So that is the question D. And question E, treatments. Treatments. So for purpose of this question, let's say the gender has two levels, male and female. So in order to do question E, you need to identify the three levels for March score. Those three levels are high level, moderate, and low. Okay, so those are the three levels, high, moderate, low. And then for gender, we have female, we have male. So the treatment, you have 6. One is high female, and then high male. So those are two treatments. The other treatment is a moderate female, moderate male, so 4. And then low female, low male. So total you have 6 treatments. Okay. Oops. So next question. 11.4, peer mentor training at a firm. Peer mentoring occurs when a more experienced employee provides one-on-one support and knowledge sharing with a less experienced employee. The Journal of Managerial Issues published a study of the impact of peer mentor training at a large software company. Participants were 222 employees who volunteered to attend a one-day peer mentor training session. One variable of interest was employees' level of competence in peer mentoring, measured on 7-point scale. The competence level of each trainee was measured at 3 different times in a study: 1 week before training, 2 days after training, and 2 months after training. One goal of the experiment was to compare the mean competence levels of the 3 time periods. Question A, identify the response variable. Response variable. So the response variable usually is the objective of the study. Okay, so the objective study, they want to, the goal, see, the objective was to compare the mean competence level. So the not include compare. It is just the mean competence levels. That is the response variable. Okay, response variable. B, identify factors and levels in the experiment. Okay, factors. The factor is one variable of interest. Mentoring. The factor is competence level. The factor, no, the factor is actually the timing. Okay. Factor is different times. Oops. Different times. That is the factor. Okay, different times. And the levels, factor levels have 3 levels. One is 1 week before, the other 2 weeks after. The last one is 2 months after. That is 3 levels. So question C, how many treatments are included in the experiment? Question C. There are 3. Okay. In this experiment, we just have 1 factor. When you have 1 factor, treatment is equal to factor levels. Question D, what type of experimental design is employed? So I will type this up, question D. Question, oops, D. It is a randomized block design. Okay, that is question D. And question E, identify the blocks. So question E, the blocks, it is 222 employees. That is the blocks, okay. All right, so this is this question. Next one is a 11 point. Oops. Next one. Just try to text mode. 11.16 replication in an experiment. Okay, so I'm going to type in the solution for this one. 11.16. Why is replication important in a complete factorial experiment? Because replication allows for an estimate of the error term in a factorial design. Okay, that is the main reason for replication. Next one, 11.17. Consider 2 by 2 factorial. How many replicants are required to estimate the interaction beta to within 2 units with 90% confidence interval? Assume the standard error of the estimate of the interaction beta is 3. Okay. For this one, I'm going to actually move my location. Sorry, I'm just move from outside. It is cold. All right, so I'm back. Sitting at my dining table. Okay, more comfortable than outside. All right, go back to the question. What is the question? 11.17. You are asked to calculate number of replications are. Okay, number of replications are. Remember the formula for calculation. So I'm going to write down so this is 11.17. The formula to calculate replication are, you use a critical value T½ alpha times standard deviation of beta over square root of R. R represents replications, number of replications, okay, equal to half with B. And in this example, the estimate of interaction of, say, beta equal to 3, the standard error for beta. So standard error for beta equal to 3, that is a given. Okay, and what else is given? Within 2 units means B equal to 2. Okay, B equal to 2. And then we are asked to solve for R. Okay, and we also need to figure out what is the T½ alpha. T½ alpha is the critical value. If you have a 90%, 90% is like this. So this is 90%. Okay, so this point is T½ alpha. So the question is, when given 90%, what is this T½ alpha? You can use table to find out. Okay, to find the critical value for T½ alpha, you also need a degree of freedom. Okay, so the degree of freedom for error, degree of freedom equal to sample size minus 4, because we have 2 by 2 factorial. Okay. Actually, we have 4 parameters. Okay. The complete model for 2 by 2 factorial experiment, I will write down here, 2 by 2 factorial experiment. The model is EY equal to beta 0 plus beta 1 x1 plus beta 2 x2, and then plus interaction term beta 3 x1 times x2. As you can see, we have beta 0, beta 1, beta 2, beta 3. So total we have 4 parameters. Okay. And for sample size, okay, sample size n, what is n? N we have 2 by 2, so 2 times 2. And we are going to repeat this r times. R is number of replications. So sample size equal to 4r, equal to 4r. And then at minimum, we require, at minimum, we require r equal to 2. Okay, so when r equal to 2, and this degree of freedom equal to 4r minus 4 equal to 4 times 2 minus 4 equal to 4. So degree of freedom equal to 4. Okay. So after you figure out that, you can use Excel to, you can use table to figure out what is the T half alpha. Okay. So maybe I will move this a little bit up. So T half alpha in Excel, you type in E equal, you type in T dot INV opening bracket half alpha. Now area to the left in Excel is based on area to the left of this critical value. So area to the left, it is 95%. This is two-tailed. Okay. And now, oops, text mode. So you plug in area to the left of critical value 0.95 degree of freedom. So typing this in Excel, and you will get 2.1318. Okay. And once you have this T half alpha critical value plug in equation, so 2.1318 equal to, remember the standard deviation for the beta is 3, that is given. Okay. This one, it is a times, multiply times, and equal to B within 2 units. Okay. So you solve for R, one equation, one unknown, you solve for R. R equal to 10.225. Okay. And this one is greater than 2. Okay, so we need to redo this process because we want to get a smaller R smaller than 10.225. Okay, want to get smaller than 10.225. So when you redo this, you need to figure out degree of freedom. And this time, you can assume R equal to 10. So degree of freedom, remember, equal to 4R minus 4. When R equal to 10, it is equal to 36. Okay. And then you go to Excel. When degree of freedom 36, what is critical value for T half alpha? You use Excel T dot INV opening bracket 0.95 degree of freedom 36. And you get a critical value 1.6 882. Okay. And then you continue solve the equation 1.6882 times 3 over square root of r equal to 2. And this time r equal to 6.413. Okay, so this r has improvement from the one we got before, 10. Okay, and then you repeat yourself again until when you stopped, until when next r is greater than this 6.4, you stop. Okay, so this time, redo it. When you redo it, again, you need degree of freedom equal to 4r minus 4. R equal to, take this value 7. Okay, and this time r equal to 24. And then get critical value for half alpha. Use Excel T dot INV 0.95, degree of freedom 24, critical value 1.711. Okay, so repeat yourself 1.711 times 3 over square root r equal to 2, and you solve for r equal to 6.59. See, this r is greater than this r. Okay, so you get final conclusion. Thus, you need to 7 replications. Okay, all right. So where is my Zoom? So that is some problem for screencasting. Go to application. So I'm going to stop recording.